So let's continue with our JavaScript development, and let's now work on functions and classes. So let's just make a new JavaScript file, save this as functions and classes.js, and let's create a function in here. Function show functions and classes. Okay, and in fact, we have been seeing functions all along. Number one, even in defining this this operator for us to run the code, we've been seeing functions, but let's introduce it a bit more formally now. And I just want to run this function. So let's just use this as a way to introduce the concept. So we can define a function in this way. So with the function keyword, and we provide our name for a function. So we can name it whatever we like within reason. There are keywords in JavaScript we don't want to overwrite. So we provide a name here, and then we use the brackets here for an argument space. So sometimes we want to pass arguments to a function, so we can do that here. And that is in effect kind of a header of a function. And then in the curly braces, we've got the code block that will run when the function is invoked. So that's defining the function, and then we invoke the function by stating its name here and with the brackets, and we can supply any arguments that we've set for the function here. So I'm just going to list the function in here, and let's define a function out here called adder. So function adder, and so receiving two arguments, x and y, and defining the code block. So now we receive x and y here. And we can, of course, log something. So console.log adding, and remember our, what do we call them? Template literals or something like that. So adding x and y. So we'll see the values there. And then the sum of those, of course, is so var sum equals x plus y. And we can show the result of that on the screen. So in this function, right, remember this is kind of the main function that's going to run for us. So in our workspace, when the document is ready, that will run. And so we are invoking this main kind of runner file or runner function. And in this runner function, we've been inserting our code. So what we can do is invoke the adder here. So we can say adder, and let's say 2,3. And then we expect to see the sum here. So let's save that, run it. And we get the expected text. Adding 2 and 3 gives us 5, okay? Now, better than this would be to receive the result as well. So instead of just console logging to the screen, we would rather save this result somewhere. We would like access to this value sum. And what we can do then is include a return. So a function can return a value as well. So in this case, we want to return the sum. And we can return any kind of object. In this case, it's a simple integer. Well, depends what x and y are. But we can return the sum, or we can return an array or an object or things like that. So in this case, we are simply returning the sum. And if you just run it like this, there's no real change, right? We've just included return sum here. The program still ran in the same way. And that's because we, in effect, ignored the fact that the value was being returned here. So to receive the value, we can define a variable here. So for example, s, and we can log that out. So we can say console.log, and let's just do it as an object. So return an object with attribute s and with the value that comes from the adder. And let's just make this 20 and maybe 35. And if we run that, So now we can see, so the same text that is being generated in the adder function appears. And then after this adder runs, it's returning sum. So sum is the result of this call to adder, and that value is being stored in S. So we can log out this value of S. And that's what we've done here. And we've done it using this curly brackets notation. So that will create an object with S and the result of S. All right, so that's how we can define a simple function. We can send arguments to the function. We can perform whatever operations we want and return a result here. And we can receive the result by just setting a variable to be equal to the call to the function. And then we can do whatever we like with the result there. Okay, so that's the basic definition of a function. Now, in JavaScript, there are some other interesting ways to create functions. So we can even create a function implicitly. So we can use actually the variable definition to create a function. So maybe let's call it subtractor. So we can create a variable called subtractor, which is actually a function. So here's a function, and we again send in two values, x and y. And this time I'm not going to console log anything, but we'll just return x minus y. Okay, so that's defined as a variable, but this variable is actually a function. So let's see what we get in this case. And I'm just going to move this down here. So let's call our result of the adder S1, and let's call S2 the subtractor. So we invoke this function subtractor and 20, 35. Excuse me. And let's see the result of that. So in our output, let's output S1 and S2. And there we can see the expected result. 20 plus 35 is 55, but 20 minus 35 is minus 15. So the subtractor has performed exactly as a function, even though we defined it using a variable type here. So you see, when we define a function in this way, we don't supply the name next to function. So in contrast to adder, where we defined this independently without a variable, we had to supply the name of the function after the keyword function. In this case, we don't supply the name after the keyword function, but we just set the variable equal to that. Then that becomes the name of the function. And in fact, in JavaScript, we are often creating so-called anonymous functions. So we don't always have to name a function to use it. And we have seen that actually, if we think about our mapping. So remember when we had our arrays 10, 20, it doesn't have to be as linear as this, right? An array can be anything like that. Then when we said map and we supplied a function in here, we didn't name that function. We just used it as if it's a function that, because we know that map is immediately going to invoke this function. So there was no reason to name it. So map would just look inside its argument space. It would find a function and just invoke that function. It doesn't need to name that function. So here, if we console log this, console.log the value, then we can see each of those values in this implicitly created list. Right, so this is an example of an anonymous function. We haven't named the function, so it's anonymous, and still it's useful. And and in fact, later on we'll see we can write many functions that use anonymous functions. And in fact, let's do something like that now. So let's say function, and let's just say operates, and let's say we receive some function f, and we receive some value x. And then we say here, return f of x. return f, or let's make it 2 arguments, x and y. So return f of x and y. And let's just clean up a little bit here so we don't need this stuff anymore. So now let's say operate, and we want f is being used as a function here. So let's send a function. Let's send the adder in first, and let's also send in some values. This time, let's just take 50 and 25. So operate adder 50 and 25. And if we run this, then you can see it's using the adder. It's console logging this stuff. And the sum of 50 and 25 is 75. And by the same token, instead of using the adder, we could use the subtractor here. And if we run this, this one doesn't have a, it doesn't console log anything. All it does is the subtractor just returns the result. And we didn't say to do anything with the result. So let's just console log this result. And we get the result, we expect 25. So that's the interesting thing. And I guess it's a bit more of modern coding where you can actually pass functions around in the argument space of other functions. So you can send functions into functions. And this is pretty mind-bending when you use it properly. It means you can write code in quite an abstract way. You can you can send particular behaviors into a function. And maybe an example of this, it's quite a simple example, but once I wrote a kind of maths tutoring application for my son to learn his operations, addition, subtraction, multiplication, division. So when I wrote that code, I just wrote separate operations like addition, subtraction, multiplication, division. And I had another function which would display the question and check his answer and all of that. And then I didn't have to rewrite that every time for a different operation. So every time I wanted him to learn a different operation, I would just update which function was being used. And so that was a nice way to abstract the display of the question from the actual computation. So that's the type of thing that this allows one to do, right? Being able to pass functions around, being able to create anonymous functions. Okay, just checking my notes here. So that's one thing we can do. We can also include functions into lists. So if we create a list A is 10, 20, and subtract, or let's just say adder, then that variable A will have a function in its list over there. So if we say console.log A, you'll see there is the adder function in there. And we can use that function, we can invoke that function in the standard way. So if we say A dot, or rather A, I guess that's the third position is 2, so A2, and if we send in 70 and 90, then we are invoking the function with the 2 arguments 70 and 90, and we get the expected, we can see it's working as expected. We can obviously then also include those, we can include functions in JSON objects. So so we can maybe do it that way. So if that's our variable b, then we can invoke that function with b.f, and we can send in our arguments again. And so we've invoked the function, which is an attribute in a JSON object. And so if we run this, then we can see the expected result again. So that's one one way. By the way, in creating these JSON objects, if you don't want to give a new name, if you just say adder like this, then the function or that position is referenced with adder in this way. In a similar way, we did talk about this before. So we said, if you have a variable x, like x is 10 here, then if you don't specify a value, right? That's, remember, in JavaScript object notation, the colon followed by the value that will establish x as the key and 10 as the value. So if you don't include a value, then the compiler will look for a variable called x, and then it will create an attribute called x, and it will use the value in the variable that it finds. So if we console log b, then you can see x is 10 as expected, even though we didn't specify the value here, we specified it there. And then also the function adder, we've just implicitly added it. So the compiler is acknowledging here there is an attribute called adder, which so happens to be a function called adder, which has these two arguments and so on. So we can include functions into our objects and into our arrays and so on. Right, so we've covered parsing, and we should also think about the scope of our variables. So our adder function that is defined with a certain argument space here. And let's say we had defined another variable out here. So var z equals 20. And let's say we try to add the value here. And I'm just going to comment out this stuff. So let's say we now console.log. Actually, let me copy this down here, because if we change this function here, it's going to invalidate this other, or it will change the result for this other code. So let's make a new function here, and let's just call this func. And so if we say here, return x minus y plus z, and let's also move this z down here. And if we console log the result of func, and func still only receives two arguments. Let's say we use 30 and 10, right? Then 30 minus 10 is 20, and then plus z would be another 20. And this does actually work. So if we run that, we get the result of 40. In other words, this function does have sight of this variable z. So this is in sharp contrast to many other languages where the scope of this variable is only in the space outside of this function, and you don't have access to z. But in JavaScript, you do have access to z, and in fact, you can even change the value of z here. So if you set z equals 50, and if you console log z after the function runs, console.log z, then you'll get the 50, right? Because we set it here. So you have full access, read and write access to variables defined outside of the function in JavaScript. One thing to notice also, let's say we don't invoke the function, right? So func is not going to run here. And we can see now the value of z, right? Number one, we, of course, don't see the logging for the function invocation. And number two, we can see that the z value is the original value. It's not affected by this. So, so number one, we can see we can directly operate on variables defined even outside of the function in JavaScript. And number two, that the function block will only run if invoked. So even though this code is present here above this point, still we didn't invoke it. We commented out this line where we were invoking it. And we were invoking it implicitly, right? So as part of console logging, we had invoked it, but that is still an invocation of that function. So the function was invoked when we had uncommented this. It was invoked and it changed the value of Z and it returned something else. So if we do invoke it, we'll see the expected result here, right? So we've sent in 30 and 10. So that is, so 30 minus 10 is 20, and then 20 plus the new value of 50 is 70. So we get the 70 here, and then we console logged the Z value, which is now 50. Right, so that's our function. And so be wary of this, that the function can affect variables that are defined outside. On the other hand, the variable x, so if we set here var x equals 200, for instance, and we invoke this function, and then we console log x here. Let's see what that does. So you can see the value of 200 is preserved. So defining x is 200 here, even though we have an x in here, this x is understood to be the x in the context of this function only. So this x is a different x to this one out here. So this x value will take on the value of 30. So the 30 inside of this function is what we have for x, but outside of this function, this value of 200 is preserved even after we invoke the function. So that value of 200 is there. So the scope of variables is an important thing to understand in terms of, well, it's really everything. If you can understand the scope of variables, and there are some kind of freaky things that we can do in JavaScript. If you do understand the scope of your variables, that's a huge step forward in terms of understanding some of the stranger parts of JavaScript. And just looking at my notes here, we have talked about the differences between var and let as well, and const. Now, I just want to show another kind of pattern that I often use in my functions. So you can see that our patterns can become, that our argument space can become quite cumbersome in a sense, right? If we have a sophisticated function that does complicated operations, it might end up having many, many parameters. And the purists will say, well, you should never have a function like that. All your functions should be, you should always break down complex tasks into small functions with few parameters. But still, even a 3-parameter space like this is something that I don't often deal with. And that's because I tend to create nice general functions. Let's create, I don't know, show editor, for example. So I tend not to show any of my arguments directly in the space. I create instead a kind of hold all variable that I call settings, right? So we create a variable called settings, and then when this function is invoked, I interpret settings. And this allows me to create defaults. So for example, if in show editor, I needed to do a few things like maybe there were a couple of variables like x, y, z, and let's say when the user invokes show editor, the user would have to send in any of these values using an object. So they might set x equals 40 and y equals 20, for example. And maybe the user forgot to include a z. So this allows me to create defaults in my function. So if I list here var x equals, and then I would say settings.x, right? So if you look at the way this function is invoked, we've got x being sent in as an attribute of an implicitly created object. So by using the curly braces, we are saying we are creating an object. and we are sending this object in with attributes X and Y having values 40 and 20 respectively. So in the function itself, I extract the value of X from settings, and I possibly don't trust that the user would always supply me with an X value, and perhaps I want to set a default value. And the way I would do that is using the double pipe operator, the OR. Remember that was OR, and I might set a value of 10 here. And similarly for Y, maybe I would say settings.Y. Maybe that has a different default value. Maybe the default value is 25. And similarly for Z, settings.Z equals, settings.Z, maybe the default value is 50. So this way I can guarantee that I have all the values that I need, that I'm not at the mercy of the user, right? You can think of different people using your function, right? Because we are not always only writing our functions for our own use. Or if you think about your future self, right? In the future, you may have forgotten how this function works and you're just playing around with it. So this is a way for us to store some defaults in our function. So if your user, which might include yourself, forgets to include an argument, you still want to guarantee that that variable exists and that it has a preferred value, then this is what you can do. And the way that we can read this is exactly as a condition as we had before. So this is a kind of implicit condition. In other words, when the compiler is working through this line, it's saying, okay, I need to create a variable X and I need to set it equal to some value. The first thing I would do is look in settings.x. And if it turns out that in settings there isn't an attribute X, then it will return a value of undefined. So undefined is considered to be on the same level as a false. So in effect, there's a false here. So now we are saying false or 10. A value of 10 is considered something more like a true. So, and we have this concept of falsy and truthy. So truthy values are numbers and strings and so on. Falsy values include undefined, well, the value false as well is, of course, falsy. So this is basically a choice between undefined and a 10. So you are at least giving the compiler the option of an undefined and a 10. And so in effect, the compiler will prefer the 10 to the undefined. And so it will set a value for X of 10. And so like in this example, we haven't supplied a Z value. So the Z value is going to be a 50. And we can test this out. So if we say console.log, and we invoke this show editor. Oops, this is here. So I need to do this here. No, sorry, that's not what I was trying to do. So if the invocation is to log out the sum of all these, X plus Y plus Z, then when we invoke show editor, X and Y will be 20, Z won't be defined, so that will get 50. So we expect to see 40 plus 20 is 60 plus 50 is 110. And let's see what we get here. So yeah, we can see that 110. Okay, so that is a frequent pattern. I avoid directly listing my arguments. I prefer to have one settings object. And the advantage of doing it this way is when I come back and read my code later on, I can see exactly what these values were, right? Compare it with the case where you had a list of functions, right? Let's just do it. Let's do another one here. Let's creatively name this show editor 2. And let's say we were receiving arguments like that, X, Y, Z in those positions. Then when I invoke this function, if I say show editor 2, even if I did include all my values and I didn't forget the Z value, still, when I read this code later on, I can't really tell what these values are referring to, right? I don't know what the 4, 5, and 6 are. Whereas when I read this line of code, I can see immediately that I'm trying to set an X value of 40 and a Y value of 20. So to me, this is much more readable. It's much more expressive than this case where I'm listing all my variables and the function is happy. But when I'm using it, and this is the more frequent use case that I'm repeatedly reusing my functions, then I can't really tell what I'm trying to do here. So that's why I much prefer this approach of creating one kind of summative settings object and listing them like this. Just to say also, there is in JavaScript, there is an arguments option that you always have access to in a function. So if I ask for the list of arguments here, so I can console.log arguments. So we haven't defined arguments anywhere out in our code. It's not in our function. So this arguments object is understood by the compiler in the context of a function to be the values that we send in here. So if I console log arguments, and I'm just going to put in a separator here. Console.log. So if I log my arguments, okay, I didn't invoke show editor 2. So let's invoke show editor 2. So if I invoke that, number one, yeah, it's looking for settings, which is not set. So let's just create settings here. So I'm just going to say var settings equals an empty object, and then it will substitute the defaults. So here, so you see, you can get an arguments object, and so arguments, number one, it just gives you a list of the values of the arguments. It looks at how you can also get the way that that function was invoked, and a couple of other things that I actually don't know about. Okay, but this can be quite useful. So sometimes when you are examining some of your old code or someone else's code and you're trying to understand, and perhaps you do have something like this, then this arguments object is quite useful. Quite often, just being able to look up how many arguments were sent in, that can also help you interpret what's coming in, and you can modify your function to be able to receive variable and arguments as well. Excuse me. Okay, so that's functions. There's another useful thing we can do, which is sometimes we do want to set a default of a false value. and so we want the case. Okay, let's do this up here. So let's just mask this out. And now let's say we wanted X to be, or to have a default of a false value. Right, so let's now just console log all these values, X, Y, Z. Okay, now if we do it this way, so let's say we don't include the X here. I'm actually not so sure what this is going to do. All right, so here we did get the false, right? So in this case, X is not defined. So so here in this statement, we return a false. So X does get the false value. But there are instances where the false is too easily overwritten. I'm just trying to think when I oh yes. So let's say we had a true value in here. So let's say we have a default value of a true, But we also want that if the user has supplied a false value here, that we would retain that false value. So at the moment, if we just run it like this without sending anything in, then X will get the value of true. Okay, so that's fine. So it's taken the default there. But now let's say we wanted X to have a value of false. So if we sent in a value of false and we ran that, we can see here we are not retaining that false, which we wanted to retain. Instead, because we have a true here, it's forcing our compiler to set a value of X, because when the compiler reads this, it sees a false here, and it has the option of taking on a true. So a true value is in a sense preferred, or it has a higher precedence. So X gets the value of true, which is not what we wanted. So we wanted to have a false. So if it's possibly the case that it's going to be a false as your value, then instead of using the double pipe, we use a double question mark like that. And in fact, the double question mark can be used for everything. And if we run this, now we can see X is correctly false. Y, so in this case, when using a double question mark, then this gives a lower precedence to the true. It says if there is any value present, as long as it's not undefined, then take on the value true. If the value is undefined, then it does still take the default value. So the double question mark will check only for undefined, and if it is undefined, it will use the other value. On the other hand, the double pipe will check to see if the value is falsy. And if the value is falsy, then it will take the other value. So the double question mark is the better way of setting your default values when using objects like this. Okay, and that's it on functions for today.